So let's take a look at the Tools menu. So the Tools screen, we have Edit Current Device Profile, the Change V-Switch, which we discussed briefly earlier. What other things that we can do here are we can set the device time, we can retrieve device time, we can reset the meter information. That is all the information, the log information, or you want to clear everything out, which we don't want to. It can be very dangerous. The security, you can enable security, which we'll talk a little bit about tomorrow. Then the device information, the option card, meter firmware updates, you can choose from here. So if you decided you want to update a firmware, this is what you would select. Then there's the manual waveform capture test mode. If you want to test the meter, utilities normally would use this function, and you want to do presets, which is a nice feature. You can test the meter, put it in test mode after you finish calibrating the meter, testing the meter. You want to adjust the registers as if the meter was never removed from service. The network card status, this shows you basically it's some status information that everything is working properly. The MAC address and so on is also provided here. So, but basically the Tools allows you to do a lot of the fine-tuning and when setting up your meter, and additional external testing and so on, as we mentioned. The current device profile, probably the most important area that we'll want to discuss, and we'll go right into that discussion. So we'll retrieve the meter programming settings from the device, and initially once you connect, you will see all the parameters that we need to set up for the meter, which are CTPT configuration, time settings, system settings, communications. You can configure the serial in that communication settings, the DNP settings, general settings on the DNP. So all this that falls under DNP is all the settings that once you enable it, they're going to be impacted by your the changes that you make in the setting. The display area basically sets up the display for the meter, how you want it viewed by the customer or whoever is looking at this. You could set it to auto scroll, or you could set it to not scroll. You could set it for all your phases, A, B, and C displayed, or at the individual A and B or A, whichever you wanted. If you wanted to just have it be observed as a voltmeter, you can just set it up as a voltmeter or current meter by unchecking these. So basically, you have a few choices you want. Depending on what you want to view, you would go ahead and select those. You want your current auto scale on or off, load bus bar, user custom configuration, which you can choose, and so on. So let's continue to go down. Briefly, we'll talk about the revenue and energy to scale, scaling. We could talk about the power energy labeling and aggregators that we mentioned earlier, and so on. But before we get into that, let's go at the beginning and start about our CTPT configuration. So the CTPT configuration is very important. You need to put in your, when you program the meter, you need to have firstly a one line or some kind of a diagram showing how the metering is going to be configured. You reference that to enter this information. You would pull that information. So in this particular case, from the drawing, I saw these are 500 to 5 CTs. It's 14 kV to 120 type PTs, and then you would determine if it's a line to line to neutral type connection. So we would need to go and determine whether it's a 3 element, a 2.5 element, or 2 CT delta. So a 3 element meter configuration requires 3 line to neutral voltages and 3 phase currents to measure 3 phase power accurately. You would choose a 2.5 element configuration where it's we call a 2.5 element Y. where the connections are made with two PTs connected line to neutral. Although it's very rare, we do find that there are some existing out in the field that you will have to make that choice, a 2.5 element. And it's a huge difference from a 2 element. Some people think you could use a delta connection for a 2.5 element Y, and that would not work out because primarily the phasing and relationship between the voltage and the current vectors would be different in a delta connection. Then we'll go down to 2CT delta, which requires two line-to-line voltages, typically VA to B, VC to B on a diagram, with B as the reference, and two phase currents, and we usually look at that as IA and IC. IA coupled with VCB and IA coupled with VAB and IC coupled with VCB. And so here you see the full range, voltage, full scale ranges, 14,400, current 500 amps, 505, the total power. The phase power is 41,156 in this case, K, and then the total power would be 3 times that at 12,470. And we see total demand distortion setting, which is 5 amps, which is a reference for total harmonics demand distortion. Okay, and then let's go down to the time settings. So we use the time settings to set up for standard time or daylight savings, the zone descriptor, what area of the world you're located in where you need to set your reference time, and the clock synchronization method. So in this case, it's set for disabled, but this meter offers a line sync and NTP option, which is great if you have an NTP clock that you can sync to, which has a satellite GPS connection. You would want to use that. That's the best option that you have to sync the time with this meter. Or you could choose a line sync, which is a 60 hertz frequency to sync the line sync. The problem with line sync and the line sync choice is that, and here, before I get into that, you have the option of 50 hertz, which is different parts of the world, South America to Europe, where you can change different frequencies. But the line sync allows you to sync to that frequency while the unit is online, while the meter is online. If there is a power outage and you actually lose, if this is the meter is powered up from the phases and you actually lose power, the meter will switch automatic to its internal clock. So either way, the meter continues to maintain the time. So we'll go to the system settings next, and that area, you can set up the meter designation, that you assign a meter name, and this meter name would be anything for, if it's a unique situation, you want to specify what that designation name is. By the way, that name, if you're a utility and using MV90, that would be your device ID name in MV90. And then there's also some area for scratchpad work where you can write in some notes, anything you want the meter to display when you first connect to it. The next option then you have are the test mode. The test mode settings. So the test mode can be set up to 10 hours. And if you look on this screen, you can have this. Right now, if I wanted to put that for 600 minutes, that's roughly 10 hours I can have. And basically, the test mode allows you to take a meter out of service, perform a test to check for accuracy, and we call it calibration, to make sure that the meter is within its recommended or the accuracy level where it should be. If it's a 0.2 meter classification, it has to meet within. It has to test within that classification. So here, when you take the meter out of service, you test the meter, you inject voltage and current into the meter, and you apply it to a standard, and you make some comparisons to see how the percentage registration, to see how far it is off. I'm kind of explaining calibration in a quick couple sentences, but basically, when you put the meter in test mode, it allows you to test the meter, and the longer you have, the window you have to test, the more time you'll have to test the meter without the meter kicking out of the test mode and interrupting your test process. So that's very important. That 10 hours is a very good amount of time. Some people take an hour, some people take 3 hours, 4 hours to do a calibration. So you want to set that based upon how you test the meter or who is testing the meter. The vector sum is just another method of way of, vector is a phasor diagram, basically calculation method for VA and H, or arithmetic sum calculation. So you have a choice. You typically leave it at the default, and it doesn't affect the computation other than using any of those methods. You won't see anything in your measurement process. The next area is the communications. Communications allows you to set up the ports, just like we talked about briefly early on, the COM1 USB port connection and COM2 485 connection. So those are what we would use if we were connecting to the meter over the optical port. We said USB, and I should say optical, over the USB connection to the front panel. It would be COM1, and in this meter, although your laptop that you're setting up the meter to connect to this port would be assigned to COM8, as we saw before. So COM8 is your going out of your laptop, connecting to this meter, which is represented here as COM1. You would need to connect at the protocol speed, at protocol of, I should say, Modbus ASCII, and the baud rate of 57600. If you don't have that setting, you will not be able to connect up to the meter using the USB to USB connection. The 485 to the rear of the meter is a Modbus RTU protocol, and the baud rate again is 576. So when you set up your connection, you would set it at Modbus RTU and 57600. We talked a little bit briefly about the DNP3. You have to enable DNP. So this is an area where you would go in and retrieve your SCADA information. Typically, the DNP setup, if it's something that you would be turning on, it usually is driven by your SCADA or RTU folks would basically tell you you need to have this enabled so they could pull DNP from an RTU. So this is the area where you would go in and turn that on. So as you go in and select all of these are all parameters associated with DNP setup. This in itself is a lengthy presentation, so it could be reserved for another time with a total different discussion. We'll just jump into the revenue and energy settings real quick. We kind of skimmed through it previously before, but we'll go over it again. So this is where you set up the number of digits that you want displayed on the register, the decimal resolution, how many digits of resolution, scaling, if you want kW, if the meter's in kW load or megawatt load, or if it's just watts. These are what you would choose from the drop down, and you generally set these all at the same. It's up to you, but basically when I set these up personally, I set them all at the same resolution, 8 digits, let's say 2-3 decimal places, and this is what it would look on the value. So there's 8 digits overall and your 3 decimal places, and it's kW. Here, if you chose M, it would be M megawatts, and so on. But this is where you would do your setting for register displaying energy scaling, or register on the front of the meter, the number of digits you want to see. Power demand for display purposes. This is an area where you would set your demand to you want it to automatically scale for display purposes. So it's pretty self-explanatory. And demand averaging is, I mentioned this briefly, between two types of demand averaging. There's block averaging and rolling. And block is basically if you were to store the energies, the average energy stored in over a certain period. In this particular case, it would be 15 minutes. So whatever energy stored in that 15 minutes, the meter would collect that bundle of energy, store it in the 15 minutes, and that's considered a block. If you're storing energy in a rolling, rolling or sliding window is a term that people use a lot. It's you would basically have data that's being sampled at a particular rate. So in this particular case, we have a 15-minute interval. We want, let's say, 3 sub-intervals. Let's say make that 5-minute intervals, and we want a 50-minute block or 50-minute interval. The advantage of having rolling is that that rolling method demand provides the highest demand that you could have. So one of those 3 5-minute intervals and that 3 15-minute intervals, whichever is highest, will be reported as the peak or the highest value for that 15-minute period. In a block, the block average that we talked about before, the block is just take an average number of whatever those are. So it typically is lower than what you will find for the 15-minute period than they roll in. So utilities like to use the rolling because it produces the highest demand over 3 5-minute intervals for a 15-minute sample period. Energy scaling we talked about, so let's go to power and energy labeling. And this is just the labeling of the meter, of the phase angle directions for the power and energy during for the meter itself. And here we have positive for quadrants 1 and 4 for watt hours and watt hours delivered, and quadrants 2 and 3 for watt hours received, power hours delivered, and so on, quadrants 1 and 2, and power factor. And then here are the labeling information. Okay, so we talked about the aggregators briefly, and this is where you would set this up. We previously mentioned this. This is a you would have your aggregators in on different options, and you would add what channels that you want selected, and you would make all your entries, select all your options depending on what you have as an option board, and you would aggregate those points. I needed to record the meter energy. There I have I can add or subtract functions in this aggregator portion, and here you have it here, add or subtract. You could add energy values, and you have a choice of different quantities that you could pull down and aggregate onto one channel. And then you have your format of how many digits you want. Display would look like almost like a separate meter, but you're adding up all the different points from the meter internally. So this is a nice thing to have for total aggregation of different data points within the meter. Cold load pickup. This is a feature that we turn on and turn off. Basically, this is from a utility point of view. You may want this because you may want to defer or not penalize a customer shortly after a power has been restored during an outage. So you want to defer a certain amount of time. Typically, industrial customers would benefit from something like this, where as power was restored, the peak wouldn't slam in the first interval, and customer would be penalized for that interval. So you would enable that. A lot of utilities defer use this option, and it varies from utility to utility how much of a period you want to defer, and we call that cold load pickup. Transformer loss compensation is something that we will get into tomorrow. It is a subject that is very important. There's obviously there's line loss compensation and transformer loss compensation. Those are the most important ones. But we'll talk about that tomorrow. Time of use, we mentioned that briefly. We could get prior billing, we could get time of use schedules, rates, and so on by enabling the time of use function. And so that's where you would enable that function. Let's look at the internal accumulators. This is an area in the meter where the pulses are being recorded internally in the meter as a separate recorder, and you can retrieve the pulse data from the meter. And that's not an optional board, that's internal to the meter, and that allows you to get that information. The next one is the optional 2 digital input pulse card. This is what we call KYZ, which is the meter itself will put out pulses to an external recorder at a pulse rate that is it's weighted that the customer can program into their recorder or their own equipment that is retrieving these pulses. So it's basically the meter is outputting pulses. In this case, it's 1.8 kWh per pulse, and this is a secondary value. In order to come up with a primary value, you would take the power ratio, which is the CT-PT ratio, multiply times this, and then give that value to the customer and program it into their equipment. And this is just your labeling that you can assign for that customer. So if you wanted to give it a name or anything, you could just go ahead and choose what you want to put in that field. CT-PT compensation, those are errors in the instrument transformers that we will also discuss tomorrow. And it basically, these are all driven by the transformer report. Basically someone testing the transformer and finding these inefficiencies or I would say minor defect, which translate into requires a translation, or I should say a correction factor, and that would be inserted into this, and that's generally what you would retrieve from that. As you can see, there are A, B, CT compensation, and that's for the CT, and so you would enter those values in. For PTs, you would do something very similar. You get the values and you would enter those in for A, B, C phases. Okay, power quality we'll get into a little bit tomorrow as well. This is where we set up all our thresholds for power quality, and again, this is something that we'll talk about tomorrow, but this is a very important feature that people like about this, the meters, that it has the ability to capture or trigger certain events if you exceed any of the thresholds that you would set up in this area. Your waveform, which is another thing in this meter, it provides waveform capture, which you have the ability to capture up to 512 samples on this meter, and that affects your total, your trigger size. So 512 samples, you have 2 triggers, you have pre and post trigger, and so this gives you ability to control what you are trying to capture by setting the sample rate. So this is pretty nice. There are waveforms that are generated as a result of setting these parameters. So let's go to the logs, historical logs. First, we talk about the log sizes. So this meter has 6 historical logs where you can set up the parameters as finest resolution at 1 minute intervals to 60-minute intervals. And so here your sliders, you can specify how large you want those logs are. So depending on how much data are, let's say if you only program a historical log 1, you probably want to extend that to a larger size. You're able to make use of the historical 5 and 6 logs if you enable vSwitch higher, which gives you more memory. So that's basically, this is your slider that controls how much data you want stored per log. So let's talk about the historical logs. Okay, so this meter has, I'll go through real quick, historical log 1, 2, 3, 4. It's pre-programmed with 1, 2, 3, 4 logs that are set up to retrieve data. So historical log 1 has volts, A to neutral, B to neutral, C to neutral, I, A, B, C, watts total, vars, frequency, and voltage. So that all that information is going to be stored in the meter. It will be stored in 50-minute blocks, and you get 22 months of data. That almost 22 and a half, 22 months, almost 2 weeks, and so it's a lot of data you can store for log 1. So this is how this was determined by the slider that we talked about before. So log 2 is set up for energy, and this is a typical log that most people use to retrieve meter data, so interval data. So in this case, this meter is programming scaled energy in an interval, delivered, which is watt hours delivered, var hours received, I should say watt hours received, var hours delivered, var hours received. And that's a 4-channel configuration. And that was selected from your energy screen. So this is your menu of choices that you could pull from what you're trying to bring in. Scaled energy, this is a subgroup of what you're looking at that will bring in the scale energy values. Scale energy in an interval, scale energy in an interval pulses. Let me just briefly go over what these are. So scale energy is basically the registers that are on the display of the meter that are brought into log files. So every time you read the meter, you take a snapshot of a reading, it comes in. It basically is a snapshot of the reading on the display, stores that into a location at a particular time. The next time you read it again, let's say you read the meter at 11 o'clock, it would post a reading for that. So this is a good way of actually capturing readings in the meter. That, let's say you wanted a reading last month at 11 o'clock at night or some event, you can go back and retrieve the historical log set for scaled energy and bring that information back. Scale energy in an interval is really the energy that's stored in that meter for that interval. So we have 15-minute blocks here, and it's calculating the total energy from that for that period. This is different than what we're talking about scaled energy, which is actually the reading itself for that time, for that interval ending. So scale energy in an interval is the total energy. And scale energy in an interval pulses are the actual pulses that are calculated in the meter for that period. So there's a pulse weighted a value that's assigned to that pulse, which would, if you multiply, let's say if it was 1.8 kWh per pulse, and you had 100 pulses, that's 1,800 kilowatt hours for that pulse, for that 50-minute interval. So that's the difference. Scale energy scaled energy in interval pulses is a weighted value, which is basically pulses coming into that interval, and there's a multiplier assigned to that. And I could go through all the others, but it's basically a similar configuration, similar meaning for each one. In this particular log 2, we chose log 2 to be scale energy. But you have a choice of many options to choose from. In the screen also you see you have your max and min. You could also program with your voltage and current. You have an enormous amount of information that you can capture. You have average demand values, and a lot of information again you can store in the meter on those in your programming. Cumulative demand, you have watts delivered, watts received. Those are your 4 choices. And timestamp, I've never used that one, but you could also profile or capture demand, last reset times, and store that in the meter. As we scroll down, we'll get down to the options card. Let's go to the option card 1. We talked about the INP 100 is a network card, and that is the allows you to set up the network communications in the meter. So here is this is the IP subnet mask. It's pretty self-explanatory. So let's go down to the services and security. And in this area, we talk about enabling the web server. The meter comes with a built-in web server, and so you can enable that so you could use any browser. In this case, port 80 is chosen. A lot of the companies might block port 80, so this gives you the ability to change that browser port number to anything other than port 80. So you have that choice. The Modbus TCP server, you want to enable that so you can do Modbus polling, and again, the default port number for Modbus is TCP port number is 502, although you have the ability to change that to any other port number, especially if you're doing port forwarding. It's something that you want to be able to change those port numbers. The next is enabled email notification. You want to enable that if you want to make use of that feature, which I'll discuss on the second day of the presentation. And so here we have, this is where you enable DNP support. Once you enable that, you could take advantage of all the different settings that we've talked about up here, and you can make changes. So that's a separate discussion in itself and very lengthy. Option 2, digital input pulse card. We talked about setting up the meter to have the ability to receive pulses from a water meter or gas meter. This is where you would set that up, and you could set it to trigger on opening, closing settings, high-speed settings, and so on. Accumulator is you may want that turned on if you want to capture all the input coming in. If you want just status information, you would just turn that on. But this is very important if you are taking impulses from another source. And again, we talk about gas and water meter, but that's typical. But it could be something else. It could be a temperature device that's pulsing. You want to record it, what that might mean. But a number of things it will take, and it's two-wire contact. So it really doesn't require much to make that connection.